This video is about polymers, and at the end of this video you should understand what a polymer is. You should be able to understand and be able to describe the two main types of polymers and give specific examples of each. So, starting with what a polymer is. It's a large, usually chain-like molecule that is built together by hooking up small molecules in long chains, and those small molecules are monomers. So a monomer is just a molecule that is able to bond repeatedly together in a long chain over and over. Some polymers are man-made, which would be those that are like the nylons, the dacrons, the teflons, things that you might know from everyday life. And if you haven't heard what some of those are, Teflon is used sometimes to coat pans, cookware, so that things don't stick. Nylon has a variety of uses from, clothing, fishing line, etc. And other polymers are naturally occurring, so things that you might find in a biochemistry situation, so life science, polysaccharides, proteins, nucleic acids. Now, just to give you an idea, a simple kind of viewpoint of the difference between a polymer and a monomer is to look at this website here. Hopefully we can get that to pull up. So here on this website you can see there's a monomer is the molecule, and I'm looking right here where the red dots are. So the monomer is a single red dot. But if we can make that red dot appear over and over and over and over and chain it up, you'll get what we would call a polymer. And a polymer could be made up of thousands of these monomers, and we're going to talk about that process next. So there are two major types of polymers. One of them is called an addition polymer, and they are formed using addition reactions, which we actually have studied already in class. And so they usually involve either compounds that have double bonds or compounds that have triple bonds. The ones that we will focus on in this class include double bonds. The other type of polymer is a condensation polymer. We haven't talked a lot about condensation reactions yet in class, but you will see that later in our, and y'all describe what that means. You might know it from biology. Now, starting with addition polymers, since you're sort of familiar with this already, an addition polymer is a polymer formed by using an addition reaction of an unsaturated monomer molecule. So for example, we could use anything that has a double bond, so an alkene, and then they'll add repeatedly to each other, and there will not be another product. They'll just keep chaining up, much like the red dots you just saw in that little animation. Some examples of addition polymers are polyethylene or polyethene. Both are acceptable. Most common names would be polyethylene, polypropylene or polypropene, polystyrene, and polyvinyl chloride. Now, you might have heard of a lot of these. The polyethylene is actually like plastics that you've maybe seen in everyday life, like in your water bottles. Polystyrene is styrofoam, and polyvinyl chloride is PVC piping. Now, how does this reaction occur? Well, what will happen is you're going to have a free radical. So if you remember, a free radical is just any molecule, in this case I'm going to call it some chain R, that has a free electron, so an unpaired electron. And they're very reactive. They want to find other electrons. Now let's say we take an alkene such as ethene. So we have this molecule. This free radical is going to attack the double bond, and when it does that, it breaks that double bond, and we know from previous experience that that double bond will open up, and what it will create is a single bond between the two carbons. Now those H's were already there, both of them, and what that allows this to do is attach the R molecule to one of those C's. But because the R had an unpaired electron, things are still going to be uneven. So now you've created a free radical on that ethene molecule, and when that has a unpaired electron, it becomes a free radical, and it's going to find another ethene molecule, and it's going to attack this one. So this free radical will attack this double bond, and it'll just keep going and going until eventually possibly two free radicals will bump into each other. But if we just looked at this next step, what we would end up with next is the R would still be there plus the ethene it attacked first. And now the new ethene is going to get attacked. So it'll attach two more C's with two more H's each. And that free radical will just now attach itself to this one. And we could keep going and going on and on and on. The only way that it will really stop is when you get two free radicals to bump into each other, making a pair, and then it'll terminate. Okay? Now, we could draw this polymer, but some chains will be maybe, let's say, 1,000 long, and others might be 2,000 long. The chains are not uniform because it does depend on when free radicals bump into each other. So we don't usually write polymers with a chemical formula. We write them with a repeat unit. So the repeat unit of this particular polymer, polyethylene, so I'm going to abbreviate it PE, polyethylene, is what we would draw as the monomer. Let me back up here. This is your monomer with the double bond. Now, if I want to show the repeat unit, I'm going to break that double bond. We know that this is what's getting repeated over and over are the C's with 4 H's. So to show that repeat unit, I'm going to draw what gets repeated, and then I'm going to put it in brackets. And then I'm going to show a little n for any number of those could be repeated. So that's an example of the repeat unit of polyethylene or polyethene. And the monomer is just the ethene molecule. Now we could do the exact same thing with polyvinyl chloride. Now, I will let you guys write down the densities, the low density PEs and the high density PEs, but you can put that repeat unit down below where I showed it to you before, so you already have that. Now, we can do the same exact thing with polyvinyl chloride. Now, polyvinyl chloride is that white piping that you might see like in homes or, you know, any kind of plumbing in newer homes. So the monomer for PVC is chloroethene. So F means that we have two carbons. Ene means that they are doubly bonded, and since it says chloroethene, one of these H's is replaced by a chlorine. So I'll just pick this one right there. And that's our monomer. Now the reaction is going to happen the same way as the one with polyethylene. Some free radical is going to attack this double bond. So now what I want you to think about is how would we write the repeat unit from that monomer? So if you kind of use the same process we used on the last one, the monomer's double bond will break. And remember, you're going to be able to attach it on either side. And then keep what was there before. So the two H's on this C, and the Cl, and the H on the other C. And then that's what's going to get repeated, however many number of times. So that is our repeat unit for PVC. So those are two examples of addition polymers. No byproduct. They just keep chaining up. Now, the last type of polymer is called a condensation polymer. And a condensation polymer is formed by reacting dissimilar difunctional groups. Now, difunctional means that there are two functional groups on one monomer. And so think of it as they have an ability to grab onto another molecule each place they have a functional group. So if they have a functional group on one end of the molecule and on the opposite end, it's like having a left hand and a right hand to grab something else. But in doing so, they usually cleave out some other molecule. So I'm going to show you what I mean. Now, IB wants you to know polyamides and polyesters. Now, polyamides are what we call nylons. And polyamides are formed from a diamine and a diacid. So I'll give you an example. Let's just pick, hopefully you remember an amine has the NH2 functional group, and an acid has the COOH functional group. Now they have to be difunctional. So whatever amine I pick, I'm just going to draw an amine, and we'll just put a carbon chain in the middle here. This is considered difunctional because there are two amine functional groups. If we were to look at some diacid, we can do the COOH, I'm just writing it a little bit backwards here, and we'll make some carbon chain in the middle again. And then on the other hand, we have to have the same functional group. So that's difunctional. Now, how does this work in a reaction? So to show you, I'm actually going to rewrite these with the bonds actually shown. So I'm going to change these, and you might have room on your paper to do the same thing. And I'm going to change the COOHs to actually look like what they really physically are representing. You should hopefully remember this from your model building kit. Now, what will happen when these two things react is that the functional groups will attract to each other. And if you notice, on one of them you have an OH, and on the other you have an H. They will bond, and this water molecule can be formed and leave. So this will get pulled out, and everything else will smush together. So after they react, you'll end up with this on one end. And now where the N on the one functional group is, it still has its H, but now it's chosen to bond to the C of the other compound. And you still have this. Now we haven't created a polymer yet. We've created definitely a much bigger molecule, but we haven't created a polymer yet because this is still difunctional. In the middle, we have on the left-hand side, this is the amine. On the right-hand side, we have the acid. And in the middle, we have the amide. Now, because it's difunctional, this could keep reacting. We could keep writing this over and over and over. But what we want to do is try to figure out what our repeat unit would be. Now, some students really struggle with this, but I'll give you the hint. To find the repeat unit, once you've joined it once, you should be able to figure out the repeat unit. Look at your left end and your right end, the things that I've underlined now in red. You know that water is a byproduct of this reaction. Okay, water was leaving this molecule, that's gone. So let's do the same thing off of our end. Let's take an H away from one end and an OH away from the other. And if we leave those as open attachment points, that could be our functional or our repeat unit. So what we're going to do for our repeat unit is write N, H, and then whatever chain was in the middle. In this case, I had made it CH2 repeated 6 times. Then we have the linkage from one functional group to the other. We have the same chain that was there before. Oops, that was a CH2. And then where we took the OH. So this here is our repeat unit. Now we could do the same thing for a polyester. Now the polyester is going to take a diacid and a diol. So a diacid, we've already seen, is going to have 2 COOH groups, and a diol is going to have 2 alcohol groups. So you can make this as easy or as complicated as need be, but let's take the diacid of COOH, and now what we'll do is we'll put just let's put a benzene molecule in the middle. That's our R group this time. And on the other end, we have to make it difunctional. So now it is a diacid. That's monomer number 1. We're going to react it with the diol. So let's have just a simple one. here. And now this is going to be formed in much the same way. Okay? If you look at the small molecule that could come off, you have OH on either end. Now you're going to make water again, so you're going to take the OH from one, it doesn't matter which, and the H from the other. And that's going to leave. And water is going to be a byproduct down here, so I'll write it H2O plus. And then what we want to do is shove the two remaining molecules together and see what we get. So we get OH, C double bond O in our benzene. And then our C double bond, now that is going to bond right to the O. And then we have our R group that was in the middle, CH2, and then we have our OH. Now, what makes this a polyester is this linkage right here. That's the ester portion of it. But if you notice, it is still difunctional because each end has a functional group. So we want to write the repeat unit. Now, to try to do that successfully, just take off an OH and an H because we lose water, and then let's write what remains. So our functional group would become, or excuse me, our repeat unit would be C double bond O for this one. We have a benzene in the middle, C double bond O, O, and then we have CH2, CH2, and now just the O. And from there, if we keep repeating that, that is our polyester. Okay, so we can talk more about these in class if you have questions on them, but that's an overview of the two types of polymers.